In college algebra, we wrapped up our combinations of functions, but it was a more complex set of problems that we wrapped up. So it was composition of functions, and you have a new symbol here. It looks like a circle right here. F composite G. And if you ever see that, it means put the function G in place of f where any x is. So on number 6a, when you read f composite G right here, you want to take all of this and put it in place of any x in the f function, so right there. Now we're going to go in reverse on part B, so you may not want to make that mark that I just made on the paper. So you start out by writing f of g of x, and I start writing function f, and I have a 3, but then I see an x, so I'm going to do parenthesis and all of g. And then close it and write the rest of function f. So if you get that far, you're probably good to go. It's just that first step that's hard. Distribute the 3. And you got it. All right, let's try G composite F. So on this one, we are going to take all of F and put it in place of the x in G. So you start by writing G, and I see an x right away, so I'll lead with a parenthesis, and we have 3x minus 4 for F, and then I go back to G. What was being done to the x? It was squared, and then plus 6. So at this point, I would write the parenthesis twice, because many people struggle to FOIL this out, especially in their head. So I would write it like that. And then you want to distribute first times first, and so on. So you want to go this times this times that, this times this times that. So you should get 4 terms on this next step. We get 9x squared minus 12x minus 12x plus 16 plus 6. And then add like terms and you're done. All right, on number 7, it's a backwards problem. They're asking you to create a function f and a function g so that if you do f composite g, you get this. So it's very backwards. Requires a lot of creativity. There's many ways to do it. The super easy way to do it, it's almost cheating, you shouldn't do it this way, is to copy what I have typed there, and then just call G x. And that's like cheating. You're not really doing anything there. So when you plug G inside of F, there's no change. You just get what we started with. But let's think of another way. What if, there's many ways to do this, no right answer. What if you let f of x be the cube root of x, and then you let g of x be x squared plus 1? Now, if you go that route, you're being creative and you're thinking of composite functions. Because when I go f composite g, I want to put g in place of that x in the f function. So I start by writing the f, and I need to put this right there. And sure enough, we have what I typed at the beginning of the problem. There's a few other ways to do it, but there's 2 ways right there. All right, one last problem we worked is kind of rough. So number 8, we have 2 fractions, which means when we do the composite, we're going to get a fraction in a fraction. F composite G means I need to put that fraction right here and right there. So it looks a little messy at the beginning. So I have 6 over x over 6 over x plus 5. Now, when you work this, I would leave the numerator alone at first. I would just focus on the denominator because we need to combine those 2 terms. So on the side, let's talk about that. How do I combine those? I need a common denominator, so maybe start by putting 5 over 1. And let's let the common denominator be x, so I can multiply this fraction by x over x. And then we have a common denominator. I can combine these 2 fractions. So my new denominator is this. Now at this point, you may see exactly what the answer is, but let's go slow, step by step. If you have a fraction over a fraction, you write the top, the numerator, and you multiply by the reciprocal. And the x's cancel out. And finally, we're left with 6 over 6 plus 5x. Now, unfortunately, it also asks for the domain. So I'm going to write a little note here. If x is in the denominator, and it is, you must find values that make it 0. So when I'm finding the denominator, I'm worried about what would make, let's change colors, what would make this denominator equal to 0? So let's set it equal to 0. Solve for x. And now you know. If I was to plug in -6/5, I would get 0. So for my domain, I need to limit it. X is not allowed to equal -6/5. But there's one more value. We crossed it out, so it's hard to remember to check for it. But in the original function, right here, is there another number I can plug in that would cause the denominator to be 0? And it's 0. So right here, the x's cancel out, but you have to take into account the original problem. And if this was 0, if I plug in 0 at the very start, I get undefined values. So, final answer, that and that. All right. See y'all later. Bye.